Hello, Algebra 3. This video is a video key on our homework assignment from lesson 6.7, which was on condensing logarithms. So let's get started with number 1. Here's number 1. It's 4 times the logarithm base 8 of u minus 2 log base 8 of v. So a couple things that jump out at me right away is I have these coefficients here in front of the logs. That means I'm going to be using the power property. And I also have this subtraction sign in between them, which means I'm going to be using the quotient property. So first, let's use the power property. So we're going to bring these coefficients into where they're going to be exponents. So I'll have the log base 8 of u to the 4th. Okay, I just moved that 4 from the coefficient spot, and it became the exponent here. I'm going to subtract log base 8 of v squared. I just moved that 2 from the coefficient spot to the exponent spot. So I've used my power property. Now I'm going to employ the quotient property, which means I'm going to have the log base 8 of u to the 4th over v squared. So what I did was I took the term here, this first term, that became my numerator. My second term here, v squared, that became my denominator. So my answer to number 1 is the log base 8 of u to the 4th over v squared. Perhaps I can make that a better looking v for you. Okay, log base 8 of u to the 4th over v squared. Here is number 2, and it's similar to number 1 in that the same two things are jumping out at me. I have coefficients in front of my logarithms. That means I'm going to use the power property because I'm going to be able to move those coefficients into the exponent spot. And I have a subtraction sign here, which means I'm going to use that quotient property. So let's use that power property first. I'm going to move each coefficient into the exponent spot. So the first one, I'll get log base 3 u to the 3rd. The second one, I'm going to get log base 3 of v to the 12th. I just moved that coefficient in to the exponent spot. Now I'm going to employ that quotient property, which means I'm going to have my log base 3, but my first term here is going to become my numerator, and my second term here will become my denominator. So what I'm going to end up with is log base 3 of u to the 3rd over v to the 12th. On number 3, I have 24 log base 4x minus 6 log base 4y. So again, I'm going to be using the power property because I have these coefficients out front, and I'm going to be using the quotient property because of my subtraction sign in the middle. So I'm going to have log base 4 of x, moving this 24 from the coefficient spot to the exponent spot. And I'm going to subtract, well, I'm going to have log base 4 of y, and I'm going to move that 6 from the coefficient spot into the exponent spot. Next, I'm going to employ that quotient property. So I'm going to have log base 4. This term x to the 24th is going to move to my numerator, and this term y to the 6th will move to my denominator. So there's my answer on number 3, where I get log base 4 of x to the 24th over y to the 6th. Okay, number 4 is going to be solved much like the first 3 were. I'm going to be using the power property to move these coefficients into the exponent spot. And I'm going to be using the quotient property because of my subtraction sign here. So let's employ that power property first. I'll get log base 4 of x, moving that 3 from the coefficient spot into the exponent spot. And I'm going to subtract log base 4 of y to the 6th, moving that 6 in from the coefficient spot to the exponent spot. Now, because I have a subtraction sign, I'm going to use my quotient property. So I'll have log base 4. This first term is going to become my numerator, and the second term will become my denominator. So my answer is log base 4 of x to the 3rd power over y to the 6th power. For number 5, we have 20 log x minus 5 log y. So again, I'm going to use the power property because I have coefficients out in front here. And I'm going to use the quotient property because I have a subtraction sign in between my two log terms there. So first, let's use that power property. I have log of x. I'm going to move that 20 from the coefficient spot into the exponent spot. Now subtract log of y, and I'm going to move that 5 from the coefficient spot to the exponent spot using my power property. Now, because I have a subtraction problem here, I can use the quotient property. So I'm going to have the log, and this term here is going to become my numerator, x to the 20th, and this term over here will become my denominator. So what I'm going to end up with after condensing it into a single logarithm, I get the log of x to the 20th power over y to the 5th power. Okay, on number 6, we have one slight difference from the first 5 problems on our assignment here, and that's that our sign, our operator in the middle here is changed from a subtraction sign to a addition sign. So what two properties am I going to use? Well, I'm going to start by using the power property still, because I have coefficients out here. So I'm going to use the power property to move the coefficients into the exponent spot. But now, because this is an addition problem, rather than using the quotient property, I'm going to be using the product property. So let's start off by using our power property, and I'm going to get log base 9 of x, moving my 12 from the coefficient spot to the exponent spot. That becomes x to the 12th. And I'm going to add the log base 9 of y, and I'm going to move that 4 from the coefficient spot to the exponent spot, so it's log base 9 of y to the 4th. Okay, now I have an addition problem. So what will happen is I'll have log base 9. If you remember, when I have addition, I use the product property. So I'm going to multiply these two terms together. So it becomes x to the 12th times y to the 4th. And that becomes my answer to number 6 is log base 9 of x to the 12th, y to the 4th. Now, one thing you may want to do when you're writing these out is put parentheses over this term here. So that way you know that you're taking the log of this entire term here and not just log base 9 of x to the 12th times y to the 4th, but you're taking the log of this entire expression here. So parentheses might help and make it more clear for the reader in that case. Okay, number 7, we're looking at log, or 3 times log base 4 of x plus 15 times log of 4 base y. So I'm going to use my power property first. So I'm going to bring this coefficient of 3, move it into the exponent spot here. And I'm going to use the power property on the second term here, moving the coefficient of 15 into the exponent spot here. Next property I'm going to use is the product property because I have an addition problem here. So I have the log base 4 of x to the 3rd times y to the 15th. And I'm going to wrap those in parentheses so we know I'm taking the log of that entire expression there. So my answer to number 7, after condensing this into a single logarithm, is the log base 4 of x to the 3rd, y to the 15th. For number 8, we are looking at 25 times the log base 5 of x plus 5 times the log base 5 of y. So again, we're going to be using our power property to move these coefficients into the exponent term. And our second step will be using the product property since we have an addition problem here. So let's employ that power property first. I'll get the log base 5 of x to the 25th power, moving that 25 into the exponent spot. Now I have log base 5 of y to the 5th power, moving this 5 from the coefficient spot into the exponent spot. Next, I'm going to use that product property. So I'll end up with log base 5 of x to the 25th times y to the 5th. I'm going to wrap that in parentheses so we know we're taking the log of that entire expression there. So my answer, number 8, becomes a log base 5 of x to the 25th times y to the 5th. Okay, number 9. I have 2 times log base 6 of a plus 12 times log base 6 of b. So I'm going to be using that power property again to move these coefficients into the exponent spot. And then I'm going to use the product property because I have an addition here. So let's use that power property first. This first term, I'll do with log base 6 of a squared, moving that 2 in from the coefficient spot into the exponent spot. And I'm going to add log base 6 of b, and I'm going to move that coefficient of 12 into the exponent spot here. Now I'm going to employ that product property because I have an addition sign here. So I'll get the log base 6 of a squared b to the 12th. I'm going to go ahead and wrap those in parentheses so I know I'm taking the log of that entire expression there. And when I condense this expression here into a single logarithm, my answer is the log base 6 of a squared b to the 12th. And our final problem for this exercise, we are going to condense this into a single logarithm. We have 6 log base 5 of x plus 2 log base 5 of y. We're going to use the power property first to bring these coefficients into the exponent term, and then we're going to use the product property because we have an addition operator here between the 2 logs. So, using the power property first, I'll have log base 5 of x, moving that 6 in from the coefficient spot into the exponent spot. I get log base 5 of x to the 6th, and I'm going to add log base 5 of y squared because I'm moving that 2 in from the coefficient spot into the exponent spot. Now I'm going to use the product property, which means I'll write a single log, so log base 5 of, and I'm going to multiply those 2 terms together, x to the 6th y squared. I'll wrap them in parentheses, so we're taking the log of that entire expression. And for number 10, I get the log base 5 of x to the 6th y squared for my answer. So that is the video key for 6.7. Hopefully that helps you out. If you're still stuck or have some questions on any of these problems, please send me an email.